Hello and welcome to Coding with GPT. In this video, I'm going to be showing you how I built a full stack web app in 6 hours using GPT-4. Well, first of all, a bit of background. I actually needed to do this. Back in 2017, I partnered with a company to make this kit. I made a course, they made a kit. Inside the kit is like this coupon redeem code, and students would enter it to get access to the course. And when students redeemed the coupon, that's when I would get paid. Things were pretty good. However, as years rolled on, I stopped making Arduino tutorials, and this website cost me about $300 to maintain because I needed to pay for hosting, I needed to pay for SSL, I needed to get my friend to maintain the site. And so I got to a point, well, now that I'm using GPT-4, maybe I could just build this site from scratch. And I wondered how long that would take. So essentially, what the site needs to do is enter a unique coupon code. It will open up the link to sign up to the course, which is going to be free instead of paid, and not allow you to do this again. So essentially, this is my Amazon AWS version, which does the same thing. And here is access to the course. So this ended up being quite a bit more complicated than I initially thought, because in order to make this, instead of $300 a year, made up out of Amazon free tier services, I had to use a rather large number of services. In fact, they are all here. I had to use Lambda, which is essentially like code that runs serverless. The functions just execute on API calls. I had to use like a managed database called DynamoDB. Then I had to access that via the API gateway. And then to host the site for free, I had to use like S3 and Cloudfront, which is sort of like a CDN thing. So really, I had to use 5 sort of managed AWS services. But yeah, I was able to do it in about 6 hours. These 3 I had never used before. These 2 I had a little bit of experience with. So what I'm going to do is essentially, show you the prompts, show you how I did it step by step, and give you some guidance on how you can replicate similar projects. But before I do that, I'd like to discuss like, why do this? I mean, I needed to do the site, but why would I spend another 5-6 hours making a tutorial? I think there's more popular video topics. I could just talk about the latest plugins or code interpreter, but I think this is worthwhile for me and hopefully for you as well. So I've got some reasons written down. First of all, this is a test, like a full stack application that uses 3 AWS managed services I never used before is a really good test of rapid learning with AI. And it's going to be challenging because AWS keeps changing its interface, and GPT-4 is limited to September 2021. So am I going to be able to do that? So I think that's an interesting challenge. Second, look, the modern internet is essentially made up out of, clouds. There's APIs and databases in the cloud accessed via those APIs, and it is these managed services. Also, Lambda is serverless, which, while it doesn't scale that well to huge applications, I think AWS gives you like 1 million free API calls in a year. So for my services, like I've never sold more than 500 kits in a year. I'm actually going to get a $300 thing for free. I'm also going to be consolidating my knowledge. Like I've done this once. By explaining it again, I'll be, really getting clear that I understand it, and also sort of giving myself a bit of revision, showing you what's possible with AI. And finally, like I really, really hope that as you follow along, you might give me some ideas of future projects, or hopefully maybe you know more about AWS than I do, and you can point me in better ways of doing things. Okay, so now that I showed you what we're building, why we're doing it, let's get started. All right, let's talk about what we are replicating. What does the site, the original site, do? It's really, really basic. You have a text input here. You put in your coupon, then you press a button. The button calls a JS function. The JS function makes an API call or a database request. So far, so good. The backend logic is you've got a database with coupons. Each coupon has a value and a Boolean. The Boolean is either true or false. If the Boolean, if redeemed is false, then essentially the user can get a link and get the site for free. If the redeemed is true, it basically the user gets a message, hey, it's already been redeemed. And if the coupon doesn't exist, hey, sorry user, go away and pay for the course, I guess. So that is how the backend works. Now, to try to basically set us up to get a big picture, I started with this prompt, and this prompt was really general. It just described the front-end behavior I told you about. It described the requirements for constrained access. I'll actually read it because it really worked well. You know, I'm doing something right here and I'm not entirely certain what it is. So I said, I have a list of unique coupons. Each coupon is 8 characters long. I would like to build a simple one-page website using these tools. Users will enter their coupon in an input, press a button. The website will pop up with this link that will be shown only once. The second time a user tries to use an already used coupon, the website will say coupon already redeemed. So finally I say, please let me know what is the most efficient way to store these coupons so they're not viewable by inspecting the page. You don't want to right-click inspect and just sort of get access. I'm happy to use AWS for backend if required. Now, this is the response. Essentially, I'm told, hey, use AWS Lambda, use DynamoDB. That is like really cost effective. And it is. So for the front end, it gave me the code. The code just worked. Like it had no formatting, but it just worked. This thing gave a correctly sort of formatted API call. It gave me Node.js code for the backend. And just for personal preference, like I've done backends with Python, I've said, hey, you know, can you do this with Fast API? No Fast API, but it used this 𝗦𝗘𝗖𝗢𝗡𝗙 library. I've never used it before. I don't even know what it stands for, but hey, like I think it's a software development toolkit for Amazon, actually. That's what it says here. And it interacts with DynamoDB. So yeah, you essentially get an overview of everything you need. I mean, I asked it this, how to set up Lambda, where to enter the Lambda code. It tells me step by step. And this really gives you sort of an overview of what the site is going to be. Now, this is the sort of structure we have. I don't have really the front end that's hosted on Amazon yet. That's the easy final part. But you have a front end that's already made for us. It works. It makes an API call. It's going to have to go via a gateway. Like it didn't mention gateway, but that was what I found out sort of soon after. You can't just access a Lambda function sort of from the open internet. You need to go through the gateway. The gateway then triggers a Lambda function. The Lambda function looks up DynamoDB. The DynamoDB gives Lambda function a result. The Lambda then sends the result to the gateway. The gateway then sends it back to the IP that requested it. So all well and good. However, AWS has 10,000 settings, and we really need to be able to test these things one at a time. And that's what I'm going to show you how to do. We are going to try to essentially go create a database, check that it works properly, and then see if Lambda can connect to the database. So like little tests, and then maybe see if our front end can reach the gateway. Kind of like try to test these things individually, because if you try to implement everything at once, you're really not even going to understand when things inevitably go wrong, what is going wrong. Okay, so let's start with DynamoDB. You will just go to AWS, log in. In fact, I'm going to open up AWS. Like you will land on this management console, and you can just type in DynamoDB. Now, when you do that, just bookmark it so you can reach it pretty easily. In the DynamoDB, you can create a table. I'll call a table test. Partition key is sort of like the main thing. I mean, Mine was coupon code. I can call this coupon code. Sort key is optional. Don't create it. Default settings. So there it is. It's creating a table called test. When it's done creating, we can sort of refresh. It's active. You can explore table items. You can create an item, coupon code, boom, boom, boom. And look, add a new attribute, Boolean, new value, redeemed. Set that to false, create item. And you've got a database item right there, right? So that's simple enough. I mean, you know, if you go back to your DynamoDB, if you click on tables, you can see your table, you can see the items in your table. Works really well. So the next component, by the way, I kind of highlighted these. The next component is how do you test that Lambda can fetch stuff from Dynamo? And for that, I don't think I'm going to need to go through the list of prompts, although I will definitely attach every single conversation into the description and maybe even post it in the comments. But the most important thing to do next is try to make sure that Lambda can reach Dynamo, because there is going to be a permission setting that you need to change. So you need to come up with a bulletproof test that basically, hey, that you're going to know whether it works or not. And the way to do that is if you go into Lambda, in my redeem coupon, the only code change, well, I made 2 code changes, but the first code change was I actually asked that, hey, is there a way for you to try to check if you can reach the table? And there is that table name for table in DynamoDB tables.all. So it looks for tables. It basically says, am I successfully connecting to DynamoDB? And yeah, if it prints tables, you are in. And in order to do that, really, you don't, I mean, I can create a test event. I can create a new event. Doesn't matter what I do. I can send an empty body save, my event name, blah. If I do the blah blah test, right? I click test here. Look at this, tables in DynamoDB. So even before even testing that your Lambda function can fetch items from DynamoDB, you should test if it can connect and essentially copy the code that I have here. You will have it accessible. Again, I'm putting all the code into a GitHub repository, which is going to be linked. So next, I'm going to explain the code that you see right here in this function. And of course, we're going to use GPT4 to do just that. So the code we got given using 𝗦𝗘𝗖𝗢𝗡𝗘𝗟 inside basically our very first conversation here, I've put in into GPT4 essentially saying, hey, give me 5 to 8 steps, citing a code block, explain this code. So it goes through and explains it. So first of all, you set up AWS DynamoDB. You essentially connect Lambda to DynamoDB, and that's what this 𝗦𝗘𝗖𝗢𝗡 module does. It's a SDK for that. Then you parse the coupon code, very neat standard JSON. You essentially take, like, you know, there's the body of the message, and then there's the key and the coupon values attached there. Then, I don't know why this is called response, but essentially you fetch the coupon, like the item from the table that has the same coupon code value. If that doesn't work, the users were going to get 500 status code, which is generally like something is generally wrong with the server. It's not really specific to the database, and I think, you know, there's probably some error code that's database specific, but this is fine. Ultimately, like, We're just trying to get it to work. Check redemption status. This little neat if statement just checks if what we pulled out of the database has actually been redeemed, if that coupon has been redeemed or not. And then you get your 200 response. I mean, the 200 response is either, hey, here is your website, or your coupon code has been redeemed. So if you unlock the link to the website, the redeemed value will become true. So it was false, now it becomes true, and it cannot be redeemed again, which is pretty much what we're looking for. Okay, this is where we're going to stop for today. My pregnant wife is about to come home. I'm about to cook for her. I will see you in the next part. So if I'm wearing something else, that's the explanation. All right, we continue. So now that you understand how this function works, perhaps there's two more things that I want to mention before we move on. One, you're probably looking at these headers here. They're going to be explained in the next spot when we deal with the API gateway. And two, in terms of testing it, I've already done a particular test event. You can create another one. Just please be sure to continue using this format. The entire sort of body, this is the body and this is the, like if body is the key, I guess the value of the body is a string. So make sure that it's formatted that way. There's actually a format JSON button here to help you with that. So I found AWS really, really supportive. Okay, so let's unpack what these are. Where do we go from there? So in the grand scheme of things, we have a database that works. We've got Lambda functions that have been tested. They work with a database. Now we're onto the gateway. And really, the gateway has got two things we need to test. First of all, can it connect to the front end? And second, can it process an API call, which then goes all the way through the Lambda function to the database? The first part is going to be pretty straightforward. Let's look at it. I mean, we're going to set up a simple hello world Lambda function that we can access through the browser, any browser, and essentially go through the gateway and see hello world from Lambda. Doing stuff more than this is going to be a bit of a challenge, but let's do the basics. So this is the GPT4 chat that kind of unpacks this. I had a problem trying to get the API to call the Lambda function, and I decided to go, well, can we just do a hello world Lambda function? And there it is. It gave me that as an example. Funnily enough, that was already sort of part of the template, which you're about to see. So let's go into AWS and do the very, very simple thing of creating a Lambda function that connects to our browser through the API gateway. Like the most basic function we can think of. I've already done one hello world, but I'm going to do another one from scratch from your benefit. For your benefit. I'll call this testing. We're going to use Python, x86 architecture. I'm not sure if ARM64 would create any issues, but I know it tends to do so with virtualization, so I am not touching it. As soon as this creates, it's going to essentially import JSON and create sort of like a hello world, but I'm going to use my hello world from GPT4. I'm going to delete this. And now I pasted it. I'm going to press deploy. Okay, so there's no imports, nothing. That's the entire function. We should see body hello world actually in the browser if we can reach it through the gateway. Okay, how do you reach it through the gateway? You're basically on the home page. You click create an API. I mean, I've only used REST. That's the one I was advised to use. It's pretty straightforward. You give it a name. I'll call it testing, description, no description, create API. Remember, we're just using a get method. So create method get tick, and we're going to call a Lambda function. Lambda proxy integration, it's recommended you take this, but I really haven't seen the need to do this. And you start typing, and we created this testing function. And we're all set up. I think all we need to do is click deploy API, new stage v1. And if we've done everything correctly, we get hello world, which is a pretty big deal. So if you go back to the PowerPoint, we now have the ability to essentially communicate at a very basic level with a GET request between our browser, our front end, and the API gateway. However, things are not super straightforward, because to do a post request, which means to essentially do something that has the potential to change the contents of a database, to send information into the server, into the backend, something called CORS comes into play, cross-origin resource sharing. You, like me before, you might have had to use CORS or get around CORS because I've used Fast API, and this is always something that's been boilerplate in API code. But through this project, I've actually had to understand it, because out of the 6 hours I spent building this thing, I was stuck on CORS for about 4 of them. So, you know, you're dealing with CORS when you see header values that essentially say access control allow origin. This allow origin is like allow everything, which is actually the perfect setting for GET requests, because there's no risk with GET requests. But once you start reaching into the database, then the best practice is to basically specify the origin, the URL of the website that's going to be making the post requests. Okay, let's unpack what I'm talking about a little bit further. So what we've done so far is we created a GET request. Sometimes you can add a body to it, but we didn't. And this GET request got us a resource. It could be a picture. It's a typical thing you get with GET requests, but in our case, it was just that hello world message. This request is considered a simple request because no data is modified. So what we want to do next is send in a coupon, and this is not a simple request. Data in the database will need to be modified. And so I shouldn't have put my picture there, but this is where a challenge is going to be. This is going to need to look up the database and try to fetch the link. And the browser is going to be asking the server, hey, are you allowed to take post requests? It's going to be checking. It's going to use CORS to essentially check that this method is going to be permitted with the server communication. So let's unpack how this is going to work. So this is our browser, this is the server, and we're going to try to simulate CORS. The first thing that's going to happen is your browser is going to send something called an options request. So our API is going to need to have an options method, and this is called a pre-flight request, and it essentially checks, hey, do you have post? Can I send you a post? And then the server is going to respond with the pre-flight response saying, hey, look, I got post, I got get, and yeah, no problem. Go ahead, send me your post request. Then I'm going to post a coupon, and then the server again has to do a response, which in our case is going to be a link to a website, but the server is going to need to also have this header as well. So you're talking two methods, post method and an options method, and both of those need headers in the API gateway. So let's go into AWS and see what this looks like. Might take me a second to pull up. Did I close AWS? I might have. Okay, I'll just open it again. Maybe the magic of editing can make this happen faster. Okay, so we're in the API gateway, and instead of doing it from scratch, which is going to take a while, I might just show you how my API is set up. There's an options method, and in this method, all of these, basically, you're going to be able to create method, and options is one of the options. You're going to need to add the headers. I'm pretty sure the headers are added in the integration response. So I've got these values from GPT4. They're actually on the chat, that same chat where I've got the hello world function. So once you've added them here, and I think they're also added, they're here by default after you've added them to the options. Access control allow origin. So the post only needs access control allow origin, and the value of that is in the options, which is, in my case, allow all origins. Not the safest, but when I do with the final implementation, that is going to work. So the reason that I'm showing you this is, know that the only thing you're going to need to modify to upgrade your API from just doing gets to accepting posts is going to be the headers in the options and in the posts. So after you've done that, you're golden. Okay, let's get back to the presentation. So here we are, basically at the easy end. We have everything working. There's a front end. I mean, in my case, I had it running on Replit. Replit has this thing where you basically host a website. You could do this on GitHub. I'm sure there's 10 other sites you can put up a static site. One thing that I perhaps forgot to mention was that from that initial HTML, which is like that basic, I did one more prompt, which you can see here, to try to give me something that looks nicer. I added a sentence, I added some divs, and I asked it, I asked it to center everything and add some divs. And then it created this lovely CSS and made things of a sort of grayish green theme. It's funny how the HTML displays in here. So what am I talking about? Back here, the front end could still move to AWS at super, super low cost. It basically costs cents a year to keep files on an S3 bucket. So I decided to basically transfer that last thing to AWS. And what that's going to take is essentially an S3 bucket to hold the files and host the website files, and a CloudFront, which is like a CDN, which allows you to access the S3 bucket. Back in the day, if you look at all the documentation, S3 buckets could just be accessed like via an IP, for example. And since then, Amazon, probably for security reasons as well as for performance reasons, like given that CloudFront sort of caches your website in different zones around the world, making it really, really fast, has gone through to this model. And basically to make that happen, it was just another prompt. I would like to load a very simple static site, 3 files only, to an S3 bucket and view it on the internet through an HTTP site URL. And it showed me how to do that in essentially these 5 steps. The 5 steps are going to be in the chat. Again, every chat is going to be in the description. And this is really, really straightforward. I mean, I might open AWS just to show you what that looks like. But yeah, it is really a matter of just following the steps. First of all, S3 buckets, the way they work is as soon as you've created one, it's just like a file storage. I mean, you can basically upload files and that's it. There are no directories or anything. You just upload a bunch of files. After you've uploaded a bunch of files, you need to then tick them, go into permissions, and there's going to be a bucket policy essentially that allows you to access these publicly. There's a couple more boxes you need to tick in terms of making sure that everything in your website is publicly accessible, which is the idea for a static website. But that is it. So for the bucket part, essentially the only thing you need to do is make sure that the files are publicly accessible. And for the CloudFront bit, you create a distribution. So this is the distribution that I've created. And you essentially go into the origins and you select, you create an origin and select the S3 bucket. And I might have missed a step or two, but again, your instructions on how to do this are laid out step by step. And I don't think that this has changed very much since GPT4's cutoff date for the data, because like I said, this worked perfectly. So this part only took me like 15 to 20 minutes. And there it is. That is the complete coupon redemption website, a full stack web app that I learned how to do and did in about 6 hours. So for me personally, I think that this experience has certainly been like very positive in terms of learning a lot. It's confidence building in terms of, hey, I could figure out how to use a lot of these managed services by myself by asking AI questions instead of like watching very, tutorials that are sort of tangential or making something different from what I'm doing. So I guess my advice to you is, now that you watch this video, instead of watching more videos like this, just jump onto ChatGPT or GPT4, even better, and try to build something. I really like what 𝗪𝗘𝗧𝗧𝗧 says about learning programming. He essentially says that everyone that he knows that is really, really good at programming learned it the same way. They set out to make a project and then they had to learn along the way. And everything they learned is essentially integrated and connected, which is what makes that knowledge stick in the brain. It's essentially a network. So yeah, that's it. That was my experience. I got a lot out of it, and I encourage you to build something similar. And if you have any questions for me, put them down in the chat. I would love to have a conversation. And if you want to criticize me getting something wrong or missing something, please put that in the chat. I'm trying to learn as well. Okay, that's it. Take care, guys.